In this video, I'm going to explain to you why the ambiguous case happens, and and if you're watching this video, thank you for watching this video. I did leave it as an option, but thank you very much, guys, for watching it. It will help you kind of develop a better understanding as to what's going on. Okay, so remember, this is only for the sine rule. You do not need to worry about SOHCAHTOA or the cosine rule. It's only for the sine rule this happens. Okay, so remember the sine A over B and the sine over A and all that stuff, and sine B over B. It's only for that. Okay, remember this example that we had with this with the triangles that had the same measurements. It had 8.56 and 5.4, and then an acute angle in this corner, and 8.6 and 5.4 and the same angle in that corner, and we tried to work out this one here. Okay, this is what happens in the sine rule. This is what's going on in the sine rule, and why you sometimes need to do 180 take away the answer that you found on the calculator. And this is why it happens, okay? It's because this side is shorter than this side, and this angle is acute, okay? And this is what happens, okay? Look at this triangle here. Now imagine that's the 8.6 there, and this is the 35 degrees here, okay? Now imagine I had a compass, and I put the needle of the compass there, and I so I have a compass like this, and here's the needle, and here's the pencil. Now imagine I put the needle on that corner there, and I set the radius to 5.4, and I kind of measured 5.4. Here's 5.4. So this is it here, 5.4. Okay. And imagine I put the needle there and the pencil there, and I drew an arc until it kind of hit that flat line there. Okay, so imagine I kind of drew this line. Imagine I extended that line all the way across my page, and then I kind of put the needle and made an arc, so it hits it here and it hits it here. Okay, now this is kind of like what's going on. Okay, if you have a look, this line here, okay, I'm actually going to need to delete some of this annotation. So this line here is 5.4, but then this line here would also be 5.4, because my compass, remember the compass, I set the width of it, the radius of it, to 5.4, so this line also has to be 5.4. Now this is what happens on the calculator. When you do sine to the -1 of something, it gives you an angle as the output. Okay, so whatever number you put in there, okay, when you do sine to the -1 of some number, it tells you the angle that would have been in that corner. Okay, but the trouble is, if you look at this triangle here, this triangle on the left is this one. Okay, but the larger triangle, let me get a highlighter so you can see this. Okay, the larger triangle, so that's this angle, this side, sorry, which is the 8.6. Then if I go down here, which is 5.4, which is the 5.4, and then all the way across to that bottom point, that's this triangle here. Look, 8.6 and 5.4. And then that bottom side, okay? So let me kind of do it in a different coloured one. So this triangle here, this one, is this one. But the outer triangle is the one on the right. But what your calculator does is, because it's set to one thing in particular, when you do sine to the -1, it works out this angle here for the larger triangle, because the calculator doesn't know the difference between this, it doesn't know that you're working on this triangle on the left or the larger triangle on the right. It doesn't really know which one you're working with, so it kind of defaults to one of them, and the one it kind of works out is this one in this corner here. So it can't work out this angle here, it can only really work out the acute angle, so it gives you this angle in this corner here. So it doesn't work out that one, it works out this acute angle in this corner here. Okay, so let me kind of delete some of this annotation. Okay, so when you do sine to the minus 1 on the sine rule, if you have this scenario where this side is shorter than this side and this angle is acute, and this is the angle you want, so the bottom right hand one, your calculator cannot distinguish between this triangle and this triangle. Okay, you can't distinguish between them. It doesn't know which one you're working with. So what it does is it just assumes that you're working on this big triangle, and then it works out this angle in this corner. Now, the reason why we have to do sometimes we have to do 180 take away the angle that the calculator gives is because of this. Because what happens is the calculator only works out this angle here. Okay? But we want this one here. But if you look at it, this is why we have to do 180 take away the angle sometimes. Okay? So remember, on the sine rule, if the angle's obtuse and you accidentally work out an acute angle, then it's probably 180 take away that. And this is the reason why. It's because the calculator works out this angle in this corner. But if you look at this triangle, that's kind of like attached. Like imagine this triangle here, but this triangle is attached to it. Okay? Then the calculator works out that angle in that corner. But if you look at it, that's an isosceles triangle, because these two sides are both 5.4. But if we want to work out that angle there, then it's really, really easy, because on an isosceles triangle, these two angles are the same. This red one here that I'm colouring in is the same as that one. So let's just call that A. And then this would also be A. But if I want to work out this obtuse angle here, then I would just need to do 180 minus that one, wouldn't I? Because it's a straight line on the bottom. Remember, angles on a straight line add up to 180. So if I want to work out this obtuse angle, then I just need to do 180 minus that angle there, which is the same as that one there. So that's why sometimes if you want to work out an obtuse angle using the sine rule, that's why you have to do 180 minus the angle the calculator gives you. Is because your calculator cannot tell the difference between these two triangles. So it can't tell the difference between this triangle and this triangle if you want to work out this corner here. Okay, so it's because that side is shorter than this side, and that's an acute angle. So it has this kind of like loci thing going on with the compass, really. So it can't tell it doesn't know the difference between that triangle and this triangle. So it works out, it just assumes you're working on the big one, so it works out this acute angle here. But using this trick, you can work out the obtuse angle, because you just got to do 180 minus the answer the calculator gives you. Okay, and that's the reason why. Okay, I mean, later on in year 11 we'll look at the graph for the sine function, which gives you another reason, another kind of in-depth knowledge as to kind of why that happens. But this is kind of like the geometric explanation as to why sometimes the sine rule doesn't work and you have to do 180 take away the angle the calculator gives you. And that's really for when you want to find an obtuse angle using the sine rule. Okay, and sometimes the sine rule gives you an obtuse angle and you don't need to worry, but you just got to watch out for that stuff. Okay, so just kind of just be careful with the sine rule. It's really deceptive sometimes, and sometimes you just need to do 180 take away the answer the calculator gives you, and then that's it, really. I mean, I can't really explain it any more than that. But if you're not happy with that, just remember with the sine rule, when you do sine to the minus 1, okay, it tends to give you an acute angle as the answer. But if you're looking for an obtuse angle and you've done all the correct working out and you've made no mistakes and you've done sine to minus 1 correctly, and then it gives you an acute answer. But if you want to work out the obtuse angle, there's 180 minus the acute answer that it gives you, and that's the answer to that question. Okay, and it's just because your calculator can't tell the difference between these two triangles, because numerically they're exactly the same. It's the exact same working out. So it will just work out this angle in this corner. So you just got to do 180 to work out the angle that in that corner. And I hope that kind of explains it. Okay, so thank you for watching the videos. Now you can have a go at some of those exam questions, and I hope that kind of explains that. And just remember, the third lesson of this week is the most important one. Thank you very much, guys. All right, thank you for watching.